So we have seen like contiguous memory location, and in this contiguous memory location, we have seen fixed size partitioning and variable size partitioning. Fixed size partitioning is also called static partitioning, and variable size partitioning is also called dynamic partitioning. In the static partitioning, we have seen the problem of internal and external fragmentation. In the dynamic size partitioning, we have seen the problem of external fragmentation. Now, in this particular example, we are going to understand that how we can deal with the first fit, best fit, and worst fit algorithms. So let's go one by one. And here we are going to see in the variable size partitioning, and then we'll go for the fixed size partitioning. This is the first fit. Then we have the best fit and worst fit. Let's see the first one. The first one related to the variable size partition. How it works. Now, let's see the first fit. Now, as you know, what is there is, this is the scenario at a particular time t1 when there is a memory is given, memory is there, and in the memory, I have given some allocation to different memory allocation, and these are the free chunk of memory. So here we have free, here we have free. This is the free chunk. This is already accommodated. Okay. Now I'm using the variable size partitioning. What variable size partitioning says that the partition is not fixed, and if the partition is not fixed, so we can have the rest of the portion after accommodating the process could be utilized. So here no internal fragmentation is possible. Now let's see, we have the process P1 which need 300 unit of memory. P2 it required 25 unit, P3 it required 125 unit, and P4 required 50 units. Now let's accommodate P1 first with the help of first fit. So what first fit says that whatever will find the first match with the required memory size, we allocate it. So let's say the first one is P1, it required 300 unit. So the first chunk of memory which is free is 150. Can we accommodate here? No, it is not possible because it's less. And the next chunk of memory is 350. Can we accommodate here? Yes, we can accommodate here. So what is the left? Left one is the 50. And we can accommodate P1 here at that particular portion, right? Now let's go to the P2. P2 required 25. First fit says that whatever will required at first, whatever we get in the first, we'll accommodate it. So because 150 is free and it is the size is also more than the required size, we can accommodate here P2. So P2 is accommodated here. What is the memory that is left? It is 120. So 125 is left. Why 125 is left? Because we have already given 25 to the process P2, right? Now the next one is P3. P3 required 125 a unit of memory. So let's start from the beginning again. Can we accommodate here at 125? 125 is there, 125 is required. Yes, we can do that because whatever the first we get the memory, we can accommodate. So P3 will be here. And the last one is P4 and it required 50. Let's scan. It is already free. Sorry, occupied. Now here it is occupied. The left is 50 and it required is 50. Yes, luckily we got the space for P4 which can accommodate. So here you can see all P1, P2, P3 and P4 can be accommodated using first fit algorithm. Now let's go to the best fit algorithm. Now what happened into the best fit algorithm? What best fit says that best fit will find out the best minimum partition which can accommodate the required process. So here for that, let's start with P1. P1 required 300. Can we get 300 from here? No. Can we get 300 from here? Yes. So here we allocate 300. So P1 will be, no doubt, it is coming here. And what is left? Left is 50. And the next one is P2. PT required only 25. Can I accommodate here? No, because best fit will scan all the partition and find out the minimum which is fulfilling the request. So here 150 is high. Let's go to the another 150. So 50 and 150, which can be best for it? 25. Best will be here. So here it will be P2. What is left? Left is 25. It is already it is leftover portion here. We can use it later on. Now let's go to the P3. P3 require 125. What is the space we have? We have 150 and we have 25. In 25 cannot be fulfilled. Here we can fulfill. So here we can accommodate P3. 125 is been used and only 25 is left. Now the next one is P4. It required 50 only. What memory we have? We have 25 memory here. We have 25 memory here. Can we accommodate here? No. Now the best fit here with the variable size partitioning is cannot accommodate. Even though there is a space, here we have 25 and here we have 25 units. If we add it, we can get 50 units. We can accommodate P4, but we cannot. This is the problem of external fragmentation, right? This is the problem of external fragmentation. Now, let's go for worst case. Now, worst case, what it do? It will scan all the possible holes and it will find out the biggest one, right? So let's go for that. Go for P1. P1 required 300. We have 150. We have 350. Obviously, this is the worst. So we'll go for here and we accommodate P1. Sorry, P1. And what is the left? Left is 50. Now P2. P2 is requiring 25. How much is left? 150 and 50. Which is the highest? Highest is 150. And it required P2 here. What is left? Left is only 125. Next is 125. What is left? 125 and 50. Which is the highest? 125. Can we accommodate? Yes. So here P3 will come. Next is P4. It required 50. I have only one choice left. P4. So you can see here in the worst scenario or the worst algorithm or worst fit algorithm, this is worst fit, this is best fit, and this is first fit. So in the worst fit algorithm, we can accommodate all. In the first fit algorithm, we can accommodate R. But in the best fit algorithm, we cannot accommodate here. So you can conclude that the variable size partitioning, in the variable size partitioning, best fit is working worst. Best fit is working as a worst algorithm in terms of accommodation of the process into the memory, right? Now, the second thing we'll see is fixed size partitioning. Let's see the fixed size partitioning. Let's see what happened into the fixed size partitioning. When we use the fixed size partitioning, then how it works. Okay. So I'm using the same scenario here, but the partition here we are talking about is the fixed size partitioning. And we know that what happened into the fixed size partitioning, once we accommodate any process, we cannot accommodate any process again into that particular portion. And that is the problem with the external internal fragmentation. And the fixed size partitioning is suffering with the internal fragmentation as well as external fragmentation. Both type of fragmentation problem it is having. Okay. All thing is now let's go for the first fit first, and then we'll go for the best fit after that. Now in the first fit, what happened? Whatever I got the first, I'll accommodate. So let's say there is a P1, it is having 300. Can I accommodate here? No, it is 150. We cannot accommodate. Can we accommodate here? Yes, I can accommodate. And this I am getting P1 here. How much is left? Left is 50. Can I use it? No, it is unused. This is internal fragmentation. Now next is P2. Can I use P2? This is a free one. Can I use P2? Yes, I can store P2 here. I can use this space, and left is 125. Now next is P3. Can we have the space? It is unused. Can I have the space further? No, I don't have any space further. Only P1 and P2 will be accommodated. Now go to the best fit in the fixed size. In the best fit, what we have to do here is, in the best fit, you can see this is 300. So 300 will be accommodated. $50 is left. Now here we have 125. Can we accommodate 125 here? Sorry, 25 here. So what best fit says, because we doesn't have any other space, see here, P2 will come. Again, 125 is left. Now go to the worst fit. Worst fit says that the worst one, right? So here the P1 will come because this is the highest space, 50 is left. And for 25, here it will come and 125 is left.